Amanda Chafin. I work at the Lane Community Technology Center in Hamilton, Ohio. Welcome to part 3 of our Snow Days series. In our first session, I showed you how to make a layered laser-cut holiday ornament that was decorated with snowflakes. In our second session, I walked you through the process of designing a 3D printed planter or vase in a cute snowman shape. We'll actually be using that project now, so it might be a good time to check out that video, because today my colleague and I will show you how to make that snowman light up.
Hi, my name is Suja Pandey. I work here at the Lane Tech Center and I am a public service associate. This is our third installation of our Snow Days series, in which we'll be making light up snowman head vases. Unlike our second installation, for this one we recommend using fake flowers, because if you use real flowers, when you water them, you'll be watering your electronics.
Start by gathering your supplies. Today you're going to need a soldering iron, lead solder, tip tinner, which is optional, a damp sponge, helping hands, which are optional, wires, wire trimmers, wire cutters, an Arduino Gemma microcontroller, 2 Arduino 12 LED Neopixel rings, a USB cord, a computer, a web browser, Arduino Software, a hot glue gun with glue, rubber bands, and tape. If you've never soldered before, don't be overwhelmed. Remember, it doesn't have to look perfect, it just has to work. All you do is use wire strippers to strip the insulation away from the ends of your wires. Then press the tip of the hot soldering iron against the pad and push about 1 millimeter of lead solder against that point. It should melt into a neat little pool of metal. When you take away the heat, the metal solidifies in place, fusing the wire to the board. Make sure to wipe the tip of the soldering iron on a damp sponge every time you finish soldering. If your tip is dirty or dull, it may help to have some tip tinner handy to keep your tip usable and shiny.
We will be using a small Adafruit Gemma, which is a small programmable microcontroller, and we will be soldering it to 2 12 LED Neopixels. We'll be connecting them all together using a technique called daisy chaining. Normally, you would just directly connect one light to one programmable microcontroller, but in this case, we wanted to do 2 lights for the 2 eyes. So we're connecting the 2 lights together and then connecting those 2 lights to the Gemma and programming them as if they're one light. What I recommend, and helped us a lot when we were making this project, is twisting your wires together. So normally when you're soldering, it's 1 wire to 1 port, and it's pretty easy to get it there. But when you have 2 wires, you risk accidentally removing one. I recommend twisting the 2 together and acting like they're 1 wire when you're putting them in the port. This last technique I actually learned while working here at the Tech Center and was probably the most helpful thing in the world. It's called tinning your leads. It's where you halfway solder your wire and the port that you're going to be connecting it to prior to connecting them. So that way when you connect them together, there's already some solder there and it just melts into place.
The wiring for this project is pretty simple. Along our daisy chain, starting with the Gemma and moving to each Neopixel in turn, we're going to wire ground to ground to ground. I recommend a black wire. V out to power to power. I recommend a red wire. And then from your Gemma to your first Neopixel, D1 to in. And then from your first Neopixel to your second Neopixel, in to out. And for those, you can use any color wire that you want. If you're enjoying this video and you want more like it, don't forget to like and subscribe, or even leave a comment. I try to answer all comments and questions in a timely manner. You can also give us a shout out on Facebook. It helps us spread the word about all the cool resources and services that the library has to offer. Once you've done your wiring, it's time to select the colors and patterns that you want for your light show. I like to use the LED Strip Effects generator. Created by Adriano and Jose Maria, you can find the generator on a popular code hosting platform called GitHub. I've linked to their generator in the description below. The first thing you do is add a strip. Then click on that strip and change the LED quantity to 24 and the pin to 1. Now, in the loop section, add an effect. Customize the animations using the sliders, and you can observe the changes that you make in real time in the strip above. Then you're going to tweak the colors, and when you have the effect you want, click the Generate button, and now copy the code. It's that easy. Now that you have the code that you want to use, you need a way to upload it to the microcontroller. That's where Arduino Software comes in. It's available for free at Arduino's website, link in the description. In Arduino Software, we're first going to open a new sketch. Then we're going to set up our preferences, so we're going to go to File and Preferences. We're going to click on the Display Line Numbers checkbox, but the important part here is Additional Boards Manager URLs. You're going to add the URL that appears on the screen. It's important that you add the URL exactly as it is written, otherwise you may get an error when you try to upload your code. Don't worry, I'll include this link in the description below. Now click OK. Before we can tell our software which board we're using, we need to install our Gemma through the Boards Manager. So go ahead and click Tools, and then Boards Manager to open the Boards Manager menu. In the search bar at the top of that menu, type the word Gemma and then press Enter. Locate the entry called Adafruit AVR Boards by Adafruit. Now click Install. Click OK. Now click Close. Now that we've installed the Gemma, we can tell our software to select the correct board. So click Tools and then Board, and you'll notice a lot more boards appear in the menu now that we installed the Adafruit AVR boards. Click our board to select it. The one you're looking for here is Adafruit Gemma AT-Tiny85, 8 MHz. Now select the programmer. The programmer is what allows you to actually burn sketches to the Arduino board. We need to point our software toward the right setting. To do that, click Tools and then Programmer, and then select the correct programmer. In this case, we're looking for USB Tiny ISP. Now it's time to install the library. A library is like a coding shorthand. Instead of typing lines and lines of meticulous code by hand, we can tell our code to look in a specific code library and just do what that says. All we need to do to use a library is install it. So click Tools and then Manage Libraries to open the Library Manager. And then in the search bar at the top, type in Adafruit Neopixel and hit Enter. Locate the Adafruit Neopixel by Adafruit Library and then click Install. And then click OK, and then click Close. Okay, remember that code that you copied? Now we're going to use it. If you've copied anything else between then and now, you're going to want to go back and hit that copy button again to make sure that you have that code ready. Now plug in the Gemma, connecting it to your computer with a USB cable, and click anywhere in the sketch, and then press Ctrl-A, or Command-A if you're using a Mac. This selects everything in the sketch. Now press Ctrl-V as in Victor, or Command-V on a Mac, to paste your generated code, completely replacing the existing code in the sketch. Before we upload this code to the Gemma, we need to verify that we've configured everything correctly. So with the Gemma plugged in, and the code complete, click the Verify button in the top corner. It looks a little like a check mark. If you've done everything correctly, the black strip along the bottom will display a report. If you've made an error, the black strip along the bottom will display an error message. These are usually pretty good about pointing you in a direction of what you might need to fix, but a good place to start is that URL that we typed into the preferences. If you spelled something wrong, just one wrong letter, one wrong underscore, that might result in an error. If no errors are present, then it's time to upload your code. With the Gemma plugged in and the code complete, press the small button on the back of your Gemma. A red light should blink. The blinking light means that the Gemma is in bootloading mode. Pro tip, the Gemma can only accept new code when the red light is blinking. With the red light blinking, click the Upload button in the top corner. It looks like an arrow. If you've done everything correctly, the Neopixel will flash and then begin your animation. Let's build a snowman. If you haven't done so already, add your snowman's eyes, nose, and mouth with a hot glue gun. Hold these parts firmly until the glue is cooled. Now poke the small end of the USB cord through the hole at the back of the snowman. Later, you can plug this into any power source that uses USB, charging bricks, power banks, computers, and so on. Connect the USB cord to the Gemma, and then place the Neopixels on the eye sockets, light side facing out. Go ahead and secure those with rubber bands, and then optionally secure the other components with tape. Now plug in and enjoy. If you are located near Hamilton, Ohio, and you'd like to learn more about laser cutting, 3D printing, or programming microcontrollers, give us a call at 513-785-2727 or email us at techcenter@elanepl.org. For hours and location information, check out our website at www.elanepl.org.